NASA had just placed the most powerful space telescope ever built above Earth. Then the first image finally arrived. But something was wrong. A star should have looked like one sharp point of light. Instead, it was surrounded by a blurry glow. So engineers checked the camera. Then another camera showed the same problem. That meant the cameras were probably fine. The problem was somewhere deeper inside Hubble. And the telescope was already hundreds of kilometers above Earth. The one part causing the problem could not simply be removed and brought home. But then, investigators found something even worse. A test on the ground had already warned them. So, how did NASA launch a telescope with a problem that had already been seen? Hubble had been launched in April 1990. The whole reason for putting it in space was to escape Earth's atmosphere. You know how stars seem to shake or twinkle when you look up at night? That happens because their light passes through moving air. A telescope on the ground has to look through all of that. Hubble would not. Above the atmosphere, it was supposed to see the universe with incredible clarity. Distant galaxies, like new stars, places humans had never seen probably before. So when those first blurry pictures appeared, people were shocked. NASA had spent years building an eye for the universe, and somehow that eye could not focus. At first, engineers did not know exactly where the problem was. Maybe Hubble was shaking, or maybe something had moved during launch. Maybe one of the smaller mirrors was in the wrong position. But both main cameras showed the same strange blur. That pointed toward the large primary mirror, the heart of the telescope. And when engineers studied the images carefully, they found the answer. The mirror had the wrong shape. Now, it was not badly scratched, it was not cracked. Actually, it was incredibly smooth. It had simply been polished into the wrong curve. Near the outside edge, it was too flat by about 2.2 microns. That is around 1/50th the width of a human hair. I mean, that sounds like nothing. But a telescope mirror has one job. Take light arriving from space and bring all of it together at exactly the same point. Hubble's mirror brought different parts of that light to slightly different points. So instead of a sharp star, it created a glowing blur. But that still left a very important question. How do you polish a mirror for years, measure it again and again, and never notice that it has the wrong shape? Investigators went back to the factory equipment used to build it, and luckily the most important testing device was still there. It was called a null corrector. The name sounds complicated, but its job was simple. It looked at the mirror and told the workers where they still needed to polish. As long as the testing device was correct, the final mirror would be correct. But inside that device, one lens was positioned about 1.3 millimeters away from where it should have been. So the machine was giving the workers the wrong target. They kept polishing until the test said the mirror was perfect, and according to that machine, it was. The mirror had been made with incredible precision, just precisely wrong. And here is where the story gets frustrating. There were other tests, and those tests did not agree with the main device. One showed that something inside the testing equipment might be wrong. Another suggested the finished mirror did not have the expected curve. So the warning was there. But the main null corrector was considered the most accurate tool. The team trusted it more than the results that disagreed with it. They decided the other tests must be wrong. Some simple independent checks were considered, but they were not performed. Cost and schedule pressure made extra testing harder to justify. So instead of asking, what if our best instrument is wrong? The project continued with the answer everyone wanted to believe. This mirror is perfect. Now, NASA had a telescope in space with a mirror it could not replace. For a moment, Hubble looked like an incredibly expensive failure, but engineers noticed something important. They knew the exact shape of the error. And if you know exactly how someone's vision is wrong, you can make glasses for it. That became the solution. They would not repair the main mirror, they would add smaller mirrors with the opposite error. Hubble's mirror was too flat. The new corrective mirrors would bend the light in the other direction. The two errors would cancel each other out, and the final image would become sharp. In December 1993, astronauts reached Hubble aboard the Space Shuttle Endeavour. During 5 spacewalks, they installed a new camera with its own corrective optics and another device called CoStar, which worked like glasses for Hubble's other instruments. Then everyone waited again. New pictures arrived. This time, the stars were sharp. The blurry telescope that had become a public embarrassment could finally see the universe the way it was meant to. And some of the most famous images in the history of astronomy came from Hubble after that repair. You know, Hubble did not fail because nobody tested the mirror. They tested it constantly. The problem was that almost every important decision depended on one device being right. When other results disagreed, people trusted the answer that looked more precise. And because that answer was wrong, the warning looked like the mistake. The mirror was off by less than the width of a human hair. But the larger failure was not inside the glass. It was the decision to trust one perfect-looking result more than the evidence around it. If you want to keep uncovering stories like this with me, subscribe to Failure Atlas and tell me in the comments, what failed the most here? The testing device, the people who dismissed the warnings, or the system that depended on one measurement? Thank you for watching and see you in the next one.